Welcome everyone to knowledge sharing sessions Wednesdays for CloudSEK. Today we have Satyam, who is a backend engineer at CloudSEK. He'll be talking about event-driven services using Lambdas. Over to you, Satyam.
Okay. Hello everyone. Thanks for joining today's session. So I will just start sharing my screen. Yeah. So today we are going to discuss about the event-driven systems using Lambda. So and also we are going to do some live coding stuff. We are going to build a Slack bot, and we will.
Satyam, actually, we can't see the screen. I think so.
Okay. Is it visible?
No. Yeah. Okay. Right now, yes.
Yeah, okay. So today we are going to discuss about the event-driven services using Lambdas, and we are also going to do a small live session in which we will build a Slack bot which will act on the events which are triggered by us itself. And also we are going to discuss how we are handling how we are handling the alerting system at CloudSEK using the event-driven services and of course the Lambdas. So first, an introduction of myself. I am Satyam Kumar, working here at CloudSEK as software engineer in Backend and Infrastructure team. And yeah, so the table of content of today's talk is, first we'll go about the overview of what exactly is event-driven services and all about the events and event-driven architectures. Then we'll go about the pros and cons of the event-driven systems and architectures, and we will have a live session on building a Slack bot, and after that we will have a discussion on how we are handling the alerting system at CloudSEK using event-driven architecture. Okay, so before going into the depth of the event-driven architecture and all, so can you guys think of a day-to-day scenario where we can relate that with our an event-driven system? So the thing which is being triggered by events. So if you guys are familiar with some of the examples, you can put in the chat box. So what exactly is event-driven architecture? So a particular system which is driven by event. So the purpose or the main focus of an event-driven system is the communication, the capturing, the processing, and the persistence of the events. So it basically have three steps or three parts of an event-driven architecture. One is the event producers, which will produce the events, which will be consumed by some other services. And there is an event broker or event resolver sort of thing, which will act as a bridge between the event producers and the event consumers. So the event producers will produce their events and they will push their events to a event broker system, and the event broker system will then enable the event subscribers to act upon those events, and we will go into the depth in the next slides. So the first thing which might come into our mind is what exactly is an event. So event is anything which is going to change. So anything which is going to change a state of a system or hardware or of a system, either it is hardware or software, we can call it as an event. So in day-to-day life also, whenever we are doing something, then there is some pros, and so there might be some reactions which might be attached to the thing which we are doing. So that we can say that we have done this, we have performed this action, and this has resulted in this particular event. And so yeah, we can relate it in that way. So okay, so why should we choose for event-driven architecture? So here we are going to discuss about some of the pros or the benefits which event-driven system gives us. So one of the first benefit which event-driven system gives us is its highly decoupled nature. So what exactly happens in event-driven system? All the systems, they are entirely decoupled. So they are not aware of what exactly other systems are doing, or which system has produced the events which they are consuming, or what is the event, or which is the system which is going to consume the events which they are producing. So one of the another benefit which we can think of in an event-driven architecture is the highly available nature of the event-driven system. So what happens in an event-driven system? So all the services, they are sort of independent. They are not dependent on any other services, and they do not interact directly either. So suppose we have an application which consists of 5 or 6 that separate decoupled systems, and they are interacting using some event brokerage system. So suppose there is a situation when one of the system or event one of the system is failed, so it will not have any effect on other systems which are working. So it will continue on working, and the client will not see that this entire system has failed, or they will not see any side effect of that. So suppose if we are not using the event driven architecture, what would happen? So there is a single large system, and if one of the part of that particular large system is failing, it will result on crashing of the entire system, and the end result will be that the users or the modules which are using that particular application, they will find that the entire system has crashed. But in event driven system, the chances of finding the end user about the failure of a particular system, that is very less. It is The event driven system is highly agile in nature. So while saying highly agile in nature, I mean to say that there is no coordination between the producers and the consumers of the service. There is no need to write custom codes to poll or filter or route events. This all will be handled by the routers. So the development process and the nature of the entire application is very agile. The ease of deployment, by saying it is so event driven services are very, so the deployment process in event driven system is very less painful. By saying that, I mean to say that suppose we have a application which consists of 5 or 6 separate services, and we are changing some particular thing of a service A. Suppose we are changing something of a service called A. So we need not to touch all other 4 working services, and we are just going to make we are going to push the service A only to the production, and we are not going to touch any other services. So it will ease the deployment process, and it will ease the pain in the deployment. So as we have discussed earlier, the service is highly available. So obviously, and we have very decoupled applications. And so if suppose we have 5 services and there is very high load on service C or service D, any particular service, so we can scale that particular service up or down accordingly, and any other services, they can remain as it is. So the performance of the event driven performance of system in a event driven architecture, that increases drastically. So the next point which I'm going to talk about is the scale and fail independently. As I have discussed that we can scale the services independently. In a similar way, if a service is failing, so it is not leading to the failure of entire application. It will lead us to the failure of that particular service only, and all other services will keep on working. So another point is the ease of audit. By saying the ease of audit, I mean to say that we have a message broker sort of thing. So we can define policies and restrict who can subscribe to that message broker, or who can publish events to that message broker. So auditing becomes very much easy when we are using any event driven architecture. So any questions you guys have about the benefits of the event driven architecture? Okay, so if you have any doubt, you can ping in the chat box. So okay, so now I'm going to talk about some of the disadvantages which we can face in an event-driven architecture. The first one is the testability. The testing of the entire application that becomes pretty hard as compared to a single service. So yeah, although we can write the unit test for particular modules, but testing the entire system and covering all the possible scenarios, that becomes very hard as compared to that becomes very hard in event driven services as compared to normal service. The another point which will add to the disadvantage of event driven architecture is the hidden nature of flow of event driven service. So by saying the hidden flow, I mean to say that just by looking at the flow of the code and the software, you cannot exactly get the entire flow of the application, because it is highly decoupled and you cannot think of all other scenarios of all other services in the single row. So you will have to find it a bit hard to get the actual flow of the applications in an event driven architectures. So the thing which was adding to the benefit or advantage of event driven architecture, that is also here. So the loosely coupled nature, it is like a double-headed sword. So by saying that, I mean to say that okay, suppose we have a service which is publishing some events to a message broker or event bus, and some other service B, it is consuming that particular event from that message bus. So what actually is happening, that this service is not directly coupled to this service A is not directly coupled to service B. So there is a gap in between the communication of the service A and service B. So it might act as a vulnerability and it can be exploited if not properly designed and if all the security checks are not up to the mark. So it can act as a disadvantages of event driven architecture also. So another thing is migration. So suppose if we have created an event driven architecture and we want for some specific reason to move it to some other architecture or some other form of architecture, then it is not very easy. So or there might be case that we want to migrate some particular service from the event driven to some other form of architecture, then this migration is not going to be very easy. So we'll have to think about lots of constraint, the data integrity, and there are many constraints which we will have to think of while migration. So the another point will be the error handling in the event driven architectures. So as until we have discussed that there can be many services which are acting in coordination with each other, but they are not directly interacting with each other. Instead, they are interacting via some form of message broker sort of thing. So suppose if there is some issue in one of our services and it is not a major issue and it is not giving us error also, so think of as it is some sort of logical error. So that logical error will continue. So if service A is publishing some event to a message broker and service B is consuming that particular event, and if there is some problem or there is a sort of logical problem in service B, then that problem will also coexist in the service B. So sort of finding the exact error sort of thing in a event driven architecture, that can be tough sometimes. So yeah, error handling can be tough. And the last point which I am going to discuss is that event driven is not a cure or not an answer of all the problems. We need not to build extra, or we need not to invest extra engineering. Also, suppose there might be scenarios where we can do it simply. So there is no need to add a message broker or queuing system and to make it to event driven system just for sake of good looking. So we should not do like that. So any questions, if you guys have, you can post to the comment box. And I'm moving forward. So now I'm going to discuss some of differences which exist between the normal request response architectures and the event driven architectures. It is just like the event driven system and the normal request response architecture. We can differentiate just by taking a normal day-to-day scenario. So so we can consider making a phone call as a request response architecture. So what happens when we are calling someone? So we are dialing their number, and we are waiting for the other people to respond to your request or respond to your call. Until then, you are waiting, and you are sort of blocked. So although you have dialed the number of particular person, or you have done your sort of what you need to do, but you need to wait for the reply of that particular user at the same time. But when you are sending someone a text message or SMS, so you are publishing your event, so you are done, you have sent your message, that's it. Now it is the task of other people to respond back to you, and to they need not to respond back to you. So you might have been asking him to do some particular task. So it is like you have published the event. Now he is a subscriber. He will respond to the event accordingly, whatever he needs to do. So one more difference which is there in the event driven and request response architecture, that is in event driven services, the services, event driven architecture, the services do not interact with each other. They do not interact directly. Instead, they use some sort of message broker or some sort of message queuing system to interact between each other. But that is not the case with a normal request response architecture. There might be the case that they are internally using some sort of event driven system, but yeah, not generally they are using. So all the systems, they are interacting. It is a possibility that they are interacting directly with each other, but in event driven system it is not the case. Okay, so event driven services are, we can say that event driven services are purely synchronous in nature, but the request response architecture or request response services, they are not entirely asynchronous. We can say that they are impurely synchronous, because the one who has requested something, they need to wait until he gets the he gets the response. So we can say that yeah, it is not purely synchronous, purely asynchronous. Sorry. Yeah. So I have created a sort of a small example of a Slack API by which we can have a look at how a event is being triggered by some sort of producer. Here it is our Slack application, and that event will be captured by some sort of service, and it will do its share of processing, and it will again publish the event, is a particular event, which in result will act as a response to the Slack channel. So as you can see in the diagram, a client will trigger a Slack event by typing to our bot. So the request will come to our API service. API service will forward that particular event request to a service. I have named it service X. So that service will do its share of processing, and it will respond back in form of an event, which will act as a response to the user. So I have created a dummy, and all this will be on AWS Lambdas. Why we are choosing AWS Lambdas, we are going to discuss next, but first we will have a look at what exactly we are planning to do. So I think my screen might be visible. So this screen is of a AWS Lambda dashboard, and I am going to change directly here so that we will test it in the real time itself. So I have prepared some stub code or some helper codes which we will need in creating our chatbot. So this is the main file or the entry file where our request will come. So what exactly this, and this is in JavaScript. So guys, if you are not familiar with JavaScript, no issues. It is not very large or very in-depth use of JavaScript. I will explain whatever I am using. So here, just this file or index.js is the entry point of our application. It is doing nothing, just receiving an event and transferring that event to a particular function which we have created as an event handler, which is in some other file. So this is the function where we are going to work, and this is the function which will handle the events or act as a, so this function will act on whatever request we get, and this function will return the response accordingly. So we have also created some more files. So it is a config file. It contains the AWS Slack bot token and the URL where we need to send the response, so that the user will see the response from the bot. And obviously you are not going to see that token, that is secret. Actually, anyway, I'm going to delete it after this presentation. Okay, so I have some more files created here. I have created a file called trigger-response.js. This file is doing nothing. This file is just creating a post request to a particular URL, and that particular URL I am taking it from the config file and just adding a
Satyam.
Yeah.
Actually, someone in chat said that they can't actually see the code.
Okay, so aren't you visible?
Visible, yes, but it's
okay.
Can you increase the font size or something?
Yeah, I'm going to increase the font size. Yeah. So is it good now?
Good.
Okay. Yeah. Okay. So this particular file, that is trigger response file, that is doing nothing. It is just sending a post request to a particular URL having a authentication token, bearer token, and that token is being provided by Slack. So we are just using that particular token to send the request back to the Slack, so that user will act and see the response in whatever they have asked the bot for. And I have created some dummy handlers which I am going to use. So I have planned to have 3 separate commands which user can interact, by using which user can interact with our Slack bot. That will be the greetings, who am I, and time, and it will have some dummy responses. So now we are going to start writing what exactly which we should do to handle whatever request, whatever event we are getting, and to send back the response. So I have got an event. The first thing we need to do is to extract the body of the event, and we will first extract the body, and then we will verify that which request or which handlers we need to use for this particular request which user has asked, and accordingly we will use that particular handler function, and we will send back the response using this particular trigger response file. So we are going to start writing. Okay, so I'm first going to print whatever I have received. So this line will print whatever request we have received from the Slack as an event. So now we need to extract the payload from the Slack event which we have received. So we will mark it as empty payload first. We will now try to extract whatever we have requested. We have received. So we need to use json.parse. This is just parsing whatever JSON file which Slack has sent to us. So it will be the event.body. If any error, we need to catch it. Error. So we are just logging whatever, if somehow there is some error in the JSON parsing, we are just logging it. And so we will need to return accordingly. So we are going returning with a status code of 500 if we are not able to pass the JSON, and the body that will contain error attribute body invalid content type or something. That's why it might have failed, because so yeah, that's it. That's the parsing of the JSON request which we have received from Slack. So now I have seen the structure of the request. That's why I am writing, so I know exactly on which attribute I need to extract to respond back to the Slack, or to get the text whatever user has asked in the chat box. So we are going to extract the Slack event that is on the event.body.event. So now we have extracted the payload in the payload variable. So we are going to use payload.event here. Now we have got the Slack event which is being triggered to us, sent to us. Now we will print whatever we have received. And that will be in the form of JSON, so we are going to stringify it. So that is just a JSON.stringify. We are using it, and we are going to just print and return that 200 status code. So we will check that whether what exactly we are receiving, and whether we are going in the right direction or not. So yeah, that's it. I think we are going to deploy whatever code we have written. Okay, so now I am going to use Slack to trigger an event to our whatever server we have created for that particular Slack bot. So now we can go to the logs and we can check whether we have received that particular event from the Slack or not. If not, we will have to, yeah, in 728 we have received a request. So we can check what exactly that request was, so that we can work accordingly. So yeah, we have received whatever we should have received, and Slack has. So whenever we are sending a message to this particular bot, so in Slack settings we have configured that you just send the same message to our server, and whatever server responds, you just type it here. So one thing is done. Slack is sending the request to our server. Now the next part will be to pass the request and send back the response back to the Slack. So here we can see that we are triggering some event using this chatbot, and we are writing a message. We have written a message to this particular bot, and it has triggered an event, and that event has been transferred to. So this event has been transferred from Slack to the API gateway which we have created, and that API gateway has transferred that particular request in the form of event to our servers, and now it has been logged. So the thing which is remaining, that we need to parse the request which we have received and send back the response. So let's do it. So we have created some of the handler functions which we need to use now. So we are sending the message hi sort of thing. So if the payload dot or event or Slack, we can use Slack event dot text dot because as we can see in the log now, okay, in the event there is a text attribute, and we are in the text we have got whatever the user has sent to the bot. So we just need to extract this field. So event we have extracted, so slackbot.text.includes let it be high here, or we can make it for capital and small case both. So now we are parsing, we know that user has sent hi to us, so we need to respond accordingly to user. So what we need to do, we have created a helper function in the handlers, and here we can see that we have created a special greeting functions which will respond to all the greetings which we have, all the greetings. So, and okay, here we are using some sort of event.meta.greetings, but we haven't received that from the user because we need to send the message now. So we need to pass that greetings attribute in the Slack event which we have received. So we are going to create it manually. Greetings, now it is, yeah. So we are using meta.greetings, okay. So it is not greetings. We have a special functions created for this purpose itself. We have a function called to find the date, and it will find that what exactly is the current time, and it will accordingly send the good morning, good afternoon, or whatever message is required. So we are sending it as a greeting attribute from this function. So we need to send meta equals to, the function name is date dot find, and this will add the meta and greeting attribute to the Slack event which we have received from Slack. So now we need to return we need to use sync here. I think it will be handled here. Yeah, handlers, we have imported handlers which we have created for this particular scenario, and inside the handlers we have a function called greetings. We just need to pass the event. So the greeting functions is requiring the event which we have received from Slack. So we will just send the event to the greetings function. Oh, okay, event, it is not event, it is Slack event, sorry. So yeah, we have passed it and we are just returning it. Okay, so yeah, that's it. It should now send back a response from the server in this particular channel itself. So if we are writing hi, hopefully we will get back a response from the server. If not, we will have to figure out something. Yeah, look, we have received, so we have sent a message called hi to our bot, and now our bot has responded as, hey, my name. It has taken my name from the Slack ID which we have provided, or which not we have, or which Slack have provided to our server, and accordingly it has found out which time it is, and it has responded with good evening message. So we have 2 more handlers which we can create. I will quickly copy whatever we have done for this. Okay, need not to have all this sort of things. Okay, we will add time, and we have it in the handler function. In the handler file we have created a time function itself which will return the time, and we have another function which returns, which is the user, the details of the user which is pinging the bot. So if we are adding who am I, then it will return whatever the details of user it has which has pinged him. Who am I? Yeah, that's it. So now let's test. Hopefully it will, all the commands will start working now. Okay, So it has responded back with the current time. I don't know why it is. Oh, okay. There, why it is sending to response? Maybe we will have to check. Okay. So if I'm typing the message, who am I? So server is responding back with your Satyam Kumar, blah blah blah, and my Slack ID is this. And for your kind information, this Slack ID is not the general Slack ID. I have created this for demo purpose only. So yeah, so this is a small example of how an event-driven service can work. So here, a event has been raised by the client. That event has been transferred to the API gateway by the Slack. So it is acting as a message broker here. So now the API gateway is transferring that particular event to our service, and our service is doing some processing. So here we are hard coding the response. There might be some machine learning models which will respond to the messages which is being provided by the user. So they will get some sort of dynamic message in the response, and after that we are again triggering a event which is going back to the Slack server, and Slack is just populating that particular response which it has received from our Slack bot server to that particular user itself. So yeah, that we can say that yeah, it is a basic small working event driven example. Okay, now any question you guys have regarding this example or anything until now? You can post in chat box or comment section. Okay, okay, so I don't find any questions in the chat box. So now I am going to go further into our presentation. So how we are handling the alerting system at CloudSEK. So we are using the same stack which I have explained in the demo. We are using AWS Lambdas. We are using DynamoDB. It is a NoSQL database provided by AWS itself, Amazon. We are using the special queuing mechanism provided by the Amazon itself, simple queuing service SQS, and the S3 for storing the whatever files or whatever files we need to store. We are using S3 for that. So this is the tech stack which we are using for handling alerting system at CloudSEK, and we will just in the next slide we will know the details of the architectural design which we are using at CloudSEK. So this is a high-level overview of whatever we are using at CloudSEK. I have prepared a video presentation also for the same, so that we can get to know the exact flow of the events in our event-driven architecture. Okay, so this diagram might look a bit messy, but I'm going to explain it with the help of an video example in the next slide, so that it can be more clear to you guys. So please, the video does not have any audio, so it just has some visual presentation of the slide which I have shown to you guys in the previous slide itself. So I'm going to decrease the playback size, making it to full screen. Okay, yeah. So the entry point for our event-based system for handling the alerts at CloudSEK, that is a dashboard API. This API is the place where all other services, we have 15 or 20 services which are interacting with CloudSEK to send their respective alerts to the clients. So they are interacting with this dashboard API itself. They are pinging this particular dashboard API, and after this dashboard API, whatever happens, that is internal. So that is being handled by the event-based architecture or event-based service which we have. So suppose we are going to with the flow of in the same flow which a request comes to our service, and how a response is sent to the clients in a similar fashion. So yeah, so a request has come to us using the API gateway. Now it has come to a sort of service or service which handles which we call as request handler. Let it be request handler. So what request handler does, that it is the main service which interact with the outer world. So request handler will send back the response to whichever model which has pinged us. So it will validate the input which we have received in form of an event, or the ping which or the request which any service has done to our service, our particular alerting system. And this request handler will validate the payload structure. If the payload structure is up to the mark, it will process, it will mark the request as processed for the, and it will send back the response to whichever model which has pinged him as status 200. So the model which has pinged us, so he know that yeah, the request has reached to our central alerting system. Now it is the job of central alerting system to do whatever they want to do to process how we want to process. So their task has been done. So this now the request handler receive the request. If it is good to go, if it find it to be good, then it marks it as so. Okay, sorry, it is lagging. Okay, so the next step comes. So what request handler does, so it dumps the request to a particular message broker. Here we are using SQS for as a message broker. It will dump that particular message to SQS and other model. So that's the job of request handler. Request handler is done. So it has got a request. It has verified the payload. If it is okay, it is fine. Then it is dumping that particular event to a queue, and it is responding back as status 200. So the task of request handler is done. Now it has nothing to do with this particular request. Now it is the job of other consumers which needs to act for this particular request. So okay, now we have got a genuine request which we need to process. So as I have told that we have around 15 or 20 different modules which send us the request to send alerts to the clients. So the payload structure will definitely be different. The 15 different databases might have been using different, so 15 different services might have been using different databases. Someone might have been using SQL, someone might have been using Mongo, someone might have been using Elastic. So our next task is to convert this particular request which we have got into a uniform format, so that the lambdas or the services which are remaining, they will process it accordingly. So we cannot have different pipelines for different models now to make it even. So the job, that particular task is being performed by the context builder itself. So what it does, that it converts the alerts which it receives from the outer world to a particular unified format, and it stores it into a local DB. So that particular local DB will be accessed by all our services. So it acts as a local copy of whatever alert which client or whatever which modules has sent to us. So now we don't need to bother about, so the upcoming lambdas need not to know about which module has sent us this particular request, or from where we need to fetch the details of the request. Anything we need not to know. So that is the task of the context builder. So that's it. It is done. Now we will move forward as. Okay, so I have mentioned some of the databases that might be true or that might not be true. I did it for a demo purpose. So there might be some MySQL or Elasticsearch or MongoDB which client or the modules are using, which are sending requests to us, and we are making a local copy, making a local unified copy of that request and storing it into our local storage. We are using DynamoDB for that particular local storage. Local storage. Yep. Okay, I need to go back a bit. So then there is a service which is called incident router. So we need to, so suppose a request has raised and we need to, and that client has asked us to send the alerts on different platforms, such as it has asked to send the alerts on emails, on Slack, on Taxi, or on WhatsApp, whatever it may be. So the task of the incident router is to find out that which are the modules which are enabled for this particular alert, or which are the modules to which this particular alert need to go. So this task is being performed by the incident router, and incident router sends the particular events which we have received and which we have created a local, which we have stored it in a local unified copy. So it routes the alerts to that particular separate pipelines. So I am going to discuss about one of the pipeline here, because it is not possible to explain all the pipelines in this short period of time. So we are going to discuss about how we are handling the email pipeline. So these are the databases which we are using for local or global storage. And now the request which incident router has routed to the email pipeline that receives to a service which we call as frequency sensor. This is a service which senses. So there are clients which want to get the emails in a couple of hours interval, or they might want to get the intervals in on hourly basis, or on 5 hours or 10 hours, whatever it may be. So we need to figure out that now. So when to process this particular event. So this task is being done by this particular service, which we are calling it here frequency sensor. So frequency sensor senses the frequency of whatever alerts which we have received, and accordingly it is sending the alert for processing. And here, so we are going to move forward in the same flow. So okay, there might be case that we need not to wait for. So suppose we have got some very high severity alerts for a particular client. So we need not to bother about that frequency sensor or the time interval, whatever we have. We just need to send it instantly. So there might be some possibility like that issue. That also. So here in the diagram we can say that if it is a very high severity issue, we are directly sending that alert to our email shooter service, which is just sending an email to the particular client. It is not sending it to it is not sending it for waiting or for it is not sending it for reports or anything like that. And if it is not a high severity issue, what exactly frequency sensor is doing, that it is sending that particular issue to a report generator service, which combines whatever alerts we have got for that particular user in last time frame. It might be 2 hours or it might be 5 hours, and it is creating a PDF report for that particular, for those number of reports, and now it is the job and the task of frequency sensor is done. Now it is the job of reports generator to combine all the alerts which we have received until now and create a PDF report out of that alerts, and store that PDF which we have created we are storing it in S3 to store it somewhere, and then need to publish the event to some event bus which might be consumed by some other services. So here the report generator is sending the event to a SQS again as a message broker service, and the SQS is then being triggered. So the SQS is now triggering the email shooter service, which in turn fetches the whatever report we have stored in the S3 and combining it in an email, attaching it in an email and sending it to the client. Oh, okay. So in the same way, we have separate pipelines for Slack applications, for Sticks applications, or Sticks alerts, or for WhatsApp alerts. So one thing which you guys can figure out here or find here, that if we are wanting to add a separate alerting, or if we are going to use a separate alerting tool or platform, so we need not to do anything. We just need to go to the incident router, and we will configure here that this is a ticketing platform which we have enabled. So if a user has subscribed for this, just send the alert to this particular pipeline, and done. We need not to change anything on our email pipeline, or in our Slack pipeline, or in our taxi pipeline. So this is the advantages which we are getting from this event-driven application, there are some more advantages also. So one of the most prominent advantage which we got by switching to this alerting service is the cost cutting. So literally we are using this service for free if we are comparing to whatever bill we are generating for all other services, and for this particular email services it is almost negligible. So the benefit which we are getting from using the lambdas now, so here we need not to be active all the times. We will just activate the lambdas, or the event bus will activate the lambdas only when there is an event to act upon, and that's how we are, at the same time we are highly available, and at the same time we are cutting our cost also. So this is the main advantage which we have which we have find out by using this, switching to this particular event driven service. So yeah, I think that's it from my side. If you guys have any questions, just ping me on the chat if you have any questions.
I think a great session, Satyam. I think if we don't have any questions, we can take the discussion over to our community.
Okay.
Yeah.
Yeah. So if you guys have any questions, just put it on our event page on the CloudSEK or whatever wherever the event page has been listed. So on the CloudSEK platform itself, so we can have the detailed question and answer session there itself.
Thank you guys. Thank you guys for joining. Thank you, Satyam.
Yeah. Thank you, everyone.